Okay, so we're continuing on with section 6. This is a continuation lesson from what we covered on Wednesday. This was a 2-day lesson, so this is wrapping it up. Again, in this section, we're talking about factoring. Again, what is factoring? Factoring is the inverse of distribution. Basically, we're taking a sentence polynomial and converting it into its parentheses of multiplication, a series of multiplication between parentheses. That's factoring in a rough sense. And then in this section, we're focusing on ax squared plus bx plus c. The only difference between this one and section 5 is that now I have some coefficient, some leading coefficient other than 1. In section 5, it was just x squared plus bx plus c. In section 6, now we're like, all right, now there's some number in front other than 1. Okay, and so because of that, we learned a new technique to factor that, and that technique involved this X method and filling out a table and basically looking for common factors for rows and columns. And the common factors that we're pulling out of the rows and columns, whatever ends up on the outside of those common factors for rows and columns, whatever ends up out there, that ends up being what will go directly into my parentheses for my factors. Okay, so I demonstrated a couple of examples on Wednesday. I'm just going to go ahead and jump right into our examples for today. We're just going to do these two. All right, so just to kind of break down a couple of quick things. First off, this is pretty much exactly how you're going to see it in the section assignment, how it will show up on the chapter 2 test. You're going to be given some trinomial. Now it says ax squared plus bx plus c, but those a, b, and c's can be any number, positive or negative, whole number. And so you'll see something like this on your chapter 2 test or in this assignment, and it'll simply say factor it. It's not going to show you any of this stuff right here. It's not going to show you the X method or the table method. That's purely a technique you're expected to do on your own. And so basically, just like this last problem, you'll just get that request, factor this trinomial, and the punchline will be you'll end up with 2 binomial parentheses as a result of your factoring. Okay, so let's just go ahead and jump right in. I'm going to go through the techniques as I'm going through the solutions. So that will be built into this video. All right, so our first example, and just kind of walking through what you will be seeing in the section assignment or on your chapter 2 test. Our first example for today, you were given something like this, or this specifically. 2x squared, all right, minus 5x and minus 7. That was our first example for today. And again, what you would see on your assignment or on a test, you're here given this trinomial. We see it's a little bit different than section 5 in that we have some number out in front here, some leading coefficient other than 1 or just x squared. And so that's why it kind of qualifies under this section, but we're still going to end up with the same punchline. Now, before I get into that punchline, one thing I want to point out is what we talked about at the beginning of Wednesday's notes. The first thing you should check for in any factoring problem is, does each term have something in common? All right, we can quite plainly see that 2, 5, and 7, there is no common factor there besides 1, so there's no common number I can pull out. X squared, x, and then no x, because this one doesn't have an x, there's no letter I can factor out at the beginning. So like most problems, this will not have a greatest common factor I can pull out at the beginning. But our first example on Wednesday did have that. So always check for that first. That's usually a quick step. But in this case, I just have to kind of deal with it as it is. Okay, so you don't need to write this part, but I just want to kind of show us where we're going to end up going. When it tells us to factor this trinomial, we're going to end up with a result, an answer that's going to be some parentheses times some parentheses. And our job is to basically fill in what stuff is in here times what stuff is in here. Some polynomial times some polynomial. And in section 5, we knew automatically that the first term was x in both cases. That can't be applied here, because if I were to do an x times x, that would just be just x squared as opposed to dealing with that leading coefficient 2. And so because of that leading coefficient, I can't default to just having an x and an x in the front positions. So that's why I have to apply this this X method, table method in order to solve. So let's just jump right in. Now the X and table that I'm drawing, these are purely organizational. There's no math operations really happening here. This is just organizing my work. Okay, so there's no real meaning to an X or the table. You could actually not use them at all and just have numbers on a paper. But this is just kind of organizing my work. All right, so breaking down our process at this point. In my X, the top part of my X is going to represent my first term, 2x squared, times my last term, the -7. Now, in my solutions that are uploaded on the Google Classroom, I actually go through a step of showing like positive 2x squared times -7, and then I move on to showing you what that is. Most of us would be able to do this work in one go, in one step. So I'm just going to go ahead and do that. 2x squared times -7, don't forget about that negative sign, is going to be -14x squared. Again, first term times the last term. First term times the last term. The bottom of my X is going to be this middle term, -5x. No calculation to do there. And so now I get the same riddle that I had in section 5, where I'm going to try and come up with two values that multiply to make this top value, but also add to make this bottom value. All right, and so my suggestion here, and the way I'm going to do this, the suggestion here is to just focus on the numbers, okay? The variables will work themselves out at the end, but I'm going to just focus on the numbers here. So in other words, what two numbers will multiply together to just give me -14, but also add together to just give me -5? And my suggestion here, focus on the multiplication part, because there are a lot fewer combinations of things that will multiply to make this value than the infinite number of combinations of things I can add together to give me this value. Okay, so what values multiply together to make 14? There are actually only a couple combinations here. 14 and 1 can multiply to make 14. I'll deal with the negative sign in a minute. But for 14 and 1 can make 14. But 14 and 1 cannot add or subtract in any way to give me 5. So like as I go through my factors that make this one, the different things that multiply to make this guy, I kind of check them as I go. So 14 and 1 can multiply to make 14, but they can't add or subtract in any way to give me 5, or -5 rather. Okay, so that combo won't work. The next combo would be 7 times 2. Okay, 7 times 2 will give me 14, but and again, I'll deal with that negative in a second, but 7 and 2 I can combine to make a -5. Now, had it been positive, it would have just been 7 minus 2. The fact that it's a -5, I just swapped the negatives. So in other words, that would be a -7 and a +2. And just confirming that, -7 times +2 will in fact give me the -14. Okay, so -7 and +2. Again, my suggestion is to just deal with your numbers first, right? -7 times +2 will give me the -14. -7 plus 2 will give me the -5. If you ever find yourself like getting the right combination, just the wrong sign, just try swapping the negative signs. That usually works. Okay, and the last thing here is, because technically they're multiplying by each other to give me this term, and there's also an x squared, I need to have the x times x in order to give me the x squared. And then the combination of the like terms here, of the x's being combined, will yield me this other term with an x. So technically you don't need the x's here, but I will need to add this x in for my table. Okay, so again, there's the answer to my riddle. What two values multiply to make the top, but also add together to make the bottom. So now I'm going to fill out my table. Top left square of my table is going to be the first term in my trinomial. In this case, positive 2x squared. Positive 2x squared. The bottom right square of my table is going to be the last term. Don't forget about the negative signs there. So that's a -7 for my last term. And just kind of connecting it back to our x, these two terms that we multiply together at the very first step are what give me the top of my x. So what goes here in these diagonal boxes, these are going to be the answer to the riddle that we did in the x. the negative 7x and the positive 2x. It does not matter which one goes where. There's no real rhyme or reason to it, so it doesn't matter. I'll just put the negative 7x here and the positive 2x here. Okay, and so at this point now I'm looking to find common factors for both the columns and for both of the rows. Whatever I'm going to be factoring out for these common factors, okay, whatever I'm factoring out, those will end up being the parentheses for my factored version. Okay, and just to backtrack, these values represent the distributed version. So technically it's this, just splitting this middle term up into these two terms. Because if I were to combine negative 7x and positive 2x, I get right back here to negative 5x. This is just a version of that, but now I'm pulling out those common terms to find my factors. So I usually start with the first column. And so my suggestion again is to deal with numbers separately from letters, just to not overwhelm yourself. So looking at my 2 and negative 7, the only number that is a common factor of both 2 and negative 7 is 1. Okay, there is no common factor beyond 1. So I could put a 1 up here, but because I have x values here, let me go ahead and I'll write the 1. So it does have a 1 in common. There will always be a common factor. If there is no other common factor, the common factor is just 1, right? So now my letters, x squared and x. Well, they both share an x in common. So I have 1x is the common factor, the greatest common factor in this first column. In my second column, positive 2x and negative 7. Focusing on my numbers first, positive 2 and negative 7, just like in the other column, the only common factor there is, again, 1. 2 and 7 have nothing in common beyond 1. And because this is just an x and there is no x here, they don't have any letters or variables in common. So in other words, the only common factor in this column is just 1, and technically positive 1. Okay, so now over here, now I would find the common factors for my rows, right? And you could deal with it the same way, numbers and letters. Or another way to think about this is that this 1x is going to multiply by something to give me this 2x squared. And this positive 1 is going to multiply by something to give me this positive 2x, because that's how this table works. Whatever's on the outside multiplies together to give me, it's like filling in those multiplication charts you had in middle school and stuff, okay? So here, 1x times something gives me 2x squared. That something would be positive 2x. Another way you could have attacked that would have been my common number here. They both have a 2 in common, and they both also have an x in common. So 2x is the common factor in that row. In this row, a little more plainly to see, you can see that they both have a negative 7. This one does not have an x, so the only common factor here is a negative 7. Or you could have thought about that as 1x times something gives me negative 7x. Well, 1x times negative 7 is what gives me that. And also negative 7 times positive 1 gives me the negative 7. Okay. And so we've pulled out our common factors. And what we are left with on the outsides here, these are going to end up being our parentheses. This is going to be our factored version. So what would that look like? It does not matter which parentheses comes first. I usually put the top one first, but it doesn't matter really. So 1x plus 1, that would be my first parentheses. Well, I don't need the 1x, so I could just do x plus 1. Next parentheses, right here. Again, I could have put this first, it didn't matter, but I have positive 2x and negative 7, or 2x minus 7. And there is my factored version of the original trinomial. Okay, and so just kind of checking this work, at this point, I don't need to do this, but just so you can kind of see that this is in fact the answer. If I were to distribute and collect like terms here, I should get right back to what my original problem was. So just kind of working through that briefly. X times 2x gives me 2x squared. Again, you don't need to do this part. This is just me checking my work. And then x times negative 7 gives me negative 7x. Done with the x. Move on to the positive 1. Positive 1 times 2x is positive 2x. And positive 1 times negative 7 gives me negative 7. Now, if I were to combine these two terms, I would get right back to my 2x squared. Negative 7 positive 2 gives me negative 5 and minus 7. That is the original trinomial I had. All this demonstrated was that this factored version is the exact equivalent of that trinomial. They equal each other. This is just the factored separated version with the parentheses. This is the polynomial sentence. Okay, and just to kind of show us something right now, these values right here, this distributed version, those are each of the individual squares in my table. Okay, I'm actually going to come back to that technique in a future section because we're actually going to use a very similar concept to this a little bit later. But again, the punchline to this problem is these two factors, these two binomials are the factored version of this trinomial that we were given at the beginning. All right, let's do one more example. I'm going to go a little faster through this example, mostly just to kind of demonstrate technique again, with a little less talking on the in-between. All right, so our second example from this section, we were given negative 4x squared, minus 8x plus 5. Right, and again, we're given this trinomial, and we're asked to simply factor it. The very first thing, again, to check for, is there a common term between each of these three terms of my trinomial? Negative 4, negative 8, and 5 have nothing in common besides 1. X squared x, and then there's no x here. There is no common letter. So there is no GCF, no greatest common factor I can pull out at the beginning. Again, always worth checking for that, just like our first example on Wednesday. So nothing here to deal with that. So I just have to deal with what I have, and that's where I'm going to apply my process. Here is my x. Here's my table. Again, these are just organizational techniques. There's no real magical math operation happening here. Okay, so just as before, top of the x, first term times my last term. Just keep track of your signs. So negative 4x squared times a positive 5 would be a negative 20x squared. Bottom of my x is just the middle term, sign included, negative 8x. And so now I get my riddle. What two numbers will multiply together to give me negative 20, but also add together to give me negative 8? Again, my suggestion, start with my multiplication. There'll be far fewer combinations here. There are actually only 3 pairs of numbers I can multiply to make 20. 20 and 1, 10 and 2, 4 and 5. Okay, so one of those combinations will also combine in some way to make a negative 8. So just kind of go through them. 20 and 1. I'll deal with the negative in a second. So 20 and 1 multiply together give me 20. But I can't combine 20 and 1 in any way, shape, or form to give me negative 8. Too far apart. All right, my next combination, 10 and 2. 10 and 2 multiply to get 20, and I can combine 10 and 2 in some way to make negative 8. 10 minus 2 would just be positive 8, but I want a negative, so I need to swap those negative signs. And it's actually going to end up being negative 10 and positive 2. And that will actually track with what's going on up here because, again, this is a negative 20. And if I were to take negative 10 times positive 2, I do get the negative 20. And negative 10 plus 2 gives me negative 8. Lastly, I just add the variable back in, the x. Again, that will be necessary for when I fill it into my table. And also just to track what happened there, x times x is what gives me the x squared along with the negative 10 times 2. And then the negative 10x plus 2x is what gets me right back to the negative 8x. Okay, so now I need to fill out my table. Top left-hand box, that's going to be the first term of my trinomial, so negative 4x squared. The bottom right-hand box is the last term in my trinomial, the positive 5. And then these two diagonal boxes are what were the answer to my riddle in the x, So a negative 10x and positive 2x, it does not matter which one goes where, as long as you have both of them. And again, this represents the distributed version of me basically taking the same trinomial, but taking this middle term and splitting it into two pieces, these two pieces. And now I'm going to find common factors for both the columns and for both the rows. I always start in the first column. So dealing with my numbers first, 4 does not go into 10 evenly, but 2 does go into both of these terms. And because they're both negative, I'm actually going to pull out a negative 2. So I pull out a negative 2, and then now the letters x squared and an x, they do share an x in common. There's my greatest common factor for that first column. Second column, positive 2x and positive 5. 2 and 5 have nothing in common other than 1. And since this guy doesn't have an x, I have no letters in common, so just 1 is in common there. And it's a positive 1. All right. On to my rows. Again, I could pull out common factors, or I could deal with it like, all right, well, negative 2x has to multiply by whatever this something is to give me negative 4x squared. So that's another way to think about it. But I'll go ahead and do it the common factor. Both of these have a 2 in common. Both of them have an x in common. And just confirming my result, 2x times negative 2x gives me the negative 4x squared. 2x times a positive 1 gets me back to the 2x. So that's the correct factor. Down here, again, looking for common factors, they both have a 5 in common. 5 goes into negative 10. There is no letter in this one, so there's no letter in common here. And then just confirming my result, the 5 times the negative 2x gives me back to negative 10x, and the 5 times the positive 1 gets me back to 5. So these are my factors. Those will be my parentheses. It does not matter which parentheses comes first. I usually do the top one first, but it doesn't matter. The negative 2x and positive 1, or negative 2x plus 1. That's this one right here. And this one right here will just be my other parentheses, positive 2x and positive 5, or 2x plus 5. There is my factored version of that polynomial. If I so chose to, I could distribute and collect like terms in this binomial multiplication, and I get right back here to where I started, meaning that I did the work correctly. All right, thus ends the lesson. I'm going to stop recording.